Hey class, today we're going to learn how to convert between different compounds using the mole ratio that we learned in the last class. So we've learned about stoichiometry and basically what is the general procedure for solving stoichiometric problems, or what is the procedure to switch between compounds other than just moles of one compound to moles of another. Well, in a typical problem, you usually don't start with moles, so the first thing you want to do is convert it to moles. So if it is grams to moles, you want to use the molar mass that we did in the last chapter. If you have molecules to moles, you want to use Avogadro's number, like we did in the last chapter as well. And hopefully you remember that Avogadro's number is 6.02 times 10 to the 23rd. So once you get it into moles, what you do is you use the mole ratio from the balanced equation to go from moles of one substance to moles of another. And then once you get it to moles of the substance that you want, you can convert it to any other unit of measurement related to the mole, such as grams or molecules or formula units or atoms. So you can go anywhere. So a reminder, just from the previous lessons and last chapter, units of measurements related to the mole include the mole mass relationship. So to go from moles to grams and vice versa, you have to use 1 mole over molar mass, and it will always be 1 mole. Represented particles, things like atoms, molecules, formula units, and atoms, you're going to use Avogadro's number, and with this number, you always attach 1 to mole as well. So over here, this is just a good picture that I stole from the chemistry textbook that gives a really good handout of where to go and the steps to take. So over here, if you have a represented particle, remember these are things like molecules, formula units, atoms, and ions. You're going to start with what you're given, and you're going to multiply it by 1 mole over Avogadro's number, and then that's going to give you moles of your given. And then you take it by the mole ratio, and then you take it wherever you need to go next. Are you trying to find molecules, or are you trying to find grams? So remember, mass is grams. However, if you start with grams, to get it to moles, take 1 mole over the molar mass. That gives you moles of grams, and to change it to moles of given to moles of wanted, use mole ratio, and then from there you can go anywhere that you would like. So over here, this is a good practice equation that the book that I teach you out of gives. It says determine how many grams of water are produced in the oxidation of 1 gram of glucose, and glucose is C6H12O6. So here's the balanced chemical equation that they give you. And here it says if you want to go from grams of glucose to grams of water, there is no direct calculation. You actually have to go through these series of steps that I talked about in the last chapter, or last slide. So here they took grams and they multiplied it by the molar mass, and that gave us moles. Then they multiplied it by the mole ratio. Notice they got this 6 from the balanced equation, and they got this 1 from the balanced equation. That gives you moles of water, and then to go from moles of water to grams of water, they had to use molar mass of water as well, again. So basically, here is another equation that you could have easily done. If I wanted to find the mass of carbon dioxide, which is CO2, when 1 gram of butane, C4H10, is burned, my balanced chemical equation is such. So I start with what I'm given, 1 gram of butane. So this should actually say C4H10. If I want to go from grams, first thing you have to do is switch it to moles. So I find the molar mass of butane down here. So then I know grams of butane is canceled. Well, once I'm at moles, in order to switch to the compound I want, which is CO2, I have to use the mole ratio. So moles of CO2, or butane is what I'm trying to get rid of, and I'm trying to get moles of CO2, so I put that on top. And then you get these numbers out front by looking at the balanced chemical equation. So if you look at CO2, there's an 8 here. And then if you look at the butane, there's a 2, which goes down here as well. And then so that cancels. Now I'm still trying to get to mass of carbon dioxide. So just like the last chapter, from moles to mass, you use molar mass. So I cancel moles of CO2. I find the molar mass of CO2, and then I'm left with the unit that I want. So I just go ahead and I plug in and solve. 1 divided by 58 times 8 divided by 2 times 44 gets me 3.03 grams of CO2. So let me work out this problem, and then we'll have you try one on your own. So over here it says, calculate the number of grams of NH3 produced by the reaction of 5.4 grams of hydrogen with excess nitrogen, and it gives me my balanced equation. So you always start with what you're given, 5.4 grams of H2. I know that it's H2 because my equation says H2, and it's one of those diatomic molecules. It's barely ever found by itself. So in order to cancel grams, I have to put it on the bottom, and I want to get to moles. So I use molar mass. Whenever you use molar mass, 1 is always attached to mole, and then I have to find molar mass of H2 since there's 2 of them, which is 2.0158. So that cancels out grams of H2. Now I have to cancel out moles of H2, and I want to get to eventually to NH3. So you get these numbers out front by looking your mole ratio from the balanced equation. So I know there's 2 ammonia for every 3 hydrogen, so that cancels out H2. And then I'm left with moles of ammonia. Well, it's not asking for moles of ammonia, it's asking for grams. So I eventually have to get rid of moles, and I have to get to grams of NH3. Anytime you have moles and grams, that's molar mass, so there's always a 1 attached to that. And then you find the mass of NH3, which is 17.0307. And then, so you've canceled out moles of ammonia, you're left with grams. You can go ahead and solve across. 5.4 divided by 2.0158 times 2 divided by 3 times 17.0307 gets you about 30.4149165. And I'm going to go ahead and round to 30.4 grams. And then make sure you include your unit. You have to include NH3 so I know that's what compound you're talking about. So you go ahead and you try this one. And then we're going to walk through it. So go ahead and try it. Okay. So again, you start with always what you're given. You are given 1 gram of butane, so C4H10. In order to cancel out grams, you have to use molar mass, and you find the molar mass to be 58.123 grams of C4H10 for every 1 mole of C4H10. So that cancels grams. So then C4H10 is not the compound I want. I actually want oxygen. So I have to cancel out moles of C4H10, and I have to get to moles of O2. Now, again, I know that it's O2 because it comes from the equation, and again, that's one of those diatomic molecules. So then you look at the balanced equation and see that 13 is for oxygen, 2 here, and that cancels out moles of butane, leaves you with moles of oxygen. Well, that's not what I wanted. I wanted mass, so I need to keep going and go to grams. So moles of O2 to grams of O2. I find the molar mass to be 31.998 for every 1 mole. Canceled out moles, and you can go ahead and solve. And hopefully you got the answer 3.57839, etc. So 3.6 or 3.58 grams of O2. Okay, so how'd you do? I'm going to go ahead and do another extra practice problem because the previous ones we went from grams to grams, but know that you can also throw in molecules as well. So I'm going to go ahead and show you what to do if you see molecules. So you start with what you're given, 29.2 grams of H2O. Well, to cancel out grams, you got to put it on the bottom, and you want to always get to moles. That's your stepping stone. So for every 1 mole, there is 18.0148 grams of water. So it cancels out grams of water. Then you have water, but you want to get to oxygen. So you're switching compounds now that you get to moles using mole ratio. So mole of H2O, mole of O2. So you look and O2 has 1, H2O has 2. So that cancels out moles of H2O. And then over here, we want to get to molecules. So I do moles of O2 on the bottom. Then up here, you have to do molecules of O2. And that makes sense. Molecules should go with O2 because it's a diatomic molecule. Since there's 2 of them, it makes it a molecule. So 1 is always attached to moles, and 6.02 times 10 to the 23rd is attached to molecules. So that leaves you in the unit that you want. So when you go ahead and solve, you get about 4.88 times 10 to the 23rd. Let's label it correctly, molecules of O2. So I want you to go ahead and try to do this problem on your own, and let's see how you do. Okay. So hopefully you started this problem with what you knew, 54.1 grams of H2. To cancel out grams of H2 on the bottom, moles of H2 on the top. So since it's molar mass, 1 mole over 2.0158 cancels out grams. Now, in order to go to H2, you got to cancel it. But I want to get to water, so I have to use my mole ratio. Remember, these numbers come from this balanced equation. So 2, 2. That cancels out moles of H2. And then it's asking for molecules of water. So that's what I'm trying to get to. And I need to cancel moles by putting it on bottom. So again, this is Avogadro's number. So 1 mole and then 6.02 times 10 to the 23rd. Cancels out moles of H2. And then you can go ahead and solve 54.1 divided by 2 times 2 divided by 2. And then make sure you put this in parentheses when you plug it into your calculator. And you should get 1.62 times 10 to the 25th molecules of H2O. So how did you do? Let me know if you had any issues or problems with this. If you have any questions or need me to walk you through more examples, I'll be more than happy to. And I hope you have a good day.